as stated yesterday, we are going to learn about functions today, and they're just basic functions. We're not going to go into anything huge because this is just, in Utah, this is 8th grade math. So it's simple 8th grade algebra. So we're going to learn about functions today. I'm going to try my best to teach you the way I know how to talk, which sometimes is easier than the way that we were learning at the school. At least from what the kids told me. So, first of all, we're going to be learning about domain and range of a function. So I'm going to write a function out, and we'll explain what domain and range is and what makes it a function and not a function. So if I'm given this function, 4, 3, comma, and 1, 2. This one just won't be like wrote too big. That's fine. And usually with these, we draw these little, I don't know how to draw the brackets for the braces very well, so I just draw squiggles. That's what I do. So in a function, the basic way we describe it is there is only one input for every output. So if we're looking at this function, we just look at the x's. So look at the x coordinates, and we see, well, this is a 4, and it's a -1, and here's a 4, here's a 1. Well, right now, these are my inputs, are my x's. So x's are inputs. They are also the domain. And they want you to write the domain. When you write the domain, you write the domain from the least to greatest with no repeaters. So I will write this in braces. And I have a -1, a 1, and a 4. The range, the y's are my outputs. And that is my range. And they also want you to write it from least to greatest with no repeaters. So if I'm looking at this one, I see -3. Oh, never mind, I see -5, -3, and 2. So that's my domain and that's my range. But now we have to find out if this is an actual function or not. And it is actually not a function because I can spell, I promise. This is why I didn't go into English. It's not a function because each input has to have one output. So if we're looking at this, just look at the inputs. We have 2 4s. This right here states it is not a function because you have 2 4s. 2 inputs are having 2 completely different outputs. This is not a function. Not at all. Cool? Yes. Let's find one. Let's write one that is a function, but also will trip you up if you think it is not a function. Right here. I'm going to put it in a table. This one's put in a table. You can do that too. Okay. So if we're looking at this table, I have my inputs, ins and outs. So I'm going to put a domain and a range. Okay? Awesome, right? I think I wrote that too high, but I don't care. It's fine. You can see what I'm doing. It's my ins and my outs. Cool, right? I hope so. This camera likes to flip. See? Hey, look. In and out. So, let's write our domain, which is our x's, from least to greatest. So the least to greatest is, we have a -4, a -2, a 0, a 1 and a 3. Right? So now let's write our range, which is our y's, also least to greatest. -2, 1, 3, and 4. So now let's determine if this is a function. And this is where people get confused a little bit. Because each input can have exactly one output, but it doesn't mean that the outputs can't be the same. So looking here, we have each input. So this input has this one. So 0 has -2, -2 has 1, 3 has -2, -4 has a 4, and 1 has a 3. So looking at the inputs, they all have a different output. But some kids are like, holy crap, but there's 2 -2s on the outputs. At this point, outputs don't matter. Each input is having a different output. So even if this has the same output, the inputs are different. So this is a function. Hopefully that made a little more sense to you. If not, message me in the comments. I'll explain it a little better for you if you need it. I'm funny, I know. So this is the basis of functions. We're just trying to see if they're going to work. Mostly functions we have to write the domain and range. Domain is your x's, range is your y's. One input per output. Then there's something called a vertical line test when they're giving you a graph. Which again, I don't have a graph, which kind of sucks for me. So I'm going to just, you know what I'm doing. Graphing it up here. So I'm going to draw 2 graphs. They look awful. What am I saying, right? So let's draw this little dude here. I'm thinking about how I want to draw this. And then let's draw this guy. Oh my gosh, my phone is so popular today. Okay, or my phone. And then let's draw another one. Trying to figure out. Let's try that way. Okay. These are graphs that you will actually see in real life. Honestly, I've seen them. So now we're just going to do what they like to call a vertical line test. This is how we can also see if it's a function or not. We just take our pencil or whatever, and we just go like this. We just draw lines. All cool like this, right? And we're like, well, this one is a function. My drawing is terrible, but this is a function. Because it's not hitting the same spot on the vertical line. This one's also a function because it's not hitting the same spot on the vertical line. This one is not. Because right here, and right here, and here, and here, you're hitting the same spot. So you can't have that. So this is not a function. Vertical line test, when you're doing that on a paper, is a lot easier to see, but this is what the basis of it is. And that's, functions are relatively easy. They get harder as you progress up higher in math. These are basic functions. Yes, basic functions. All right. Let's see. I'm trying to find some ones that I have word problems. Blech, who wants those? Oh my gosh, my phone's just going off today. Okay, so this word problem states we're basically going to be using our y equals mx plus b. This is why we learned y equals mx plus b last time, is because it's actually very important. It correlates to functions, it correlates to rate of change, it correlates to a lot of stuff. So this one's called constructing functions. So I'm going to read the word problem and we're going to write down the relative information that we need from it. So the relative information we're going to need is our rate of change. I'm just going to write it this way. Rate of change and the initial value. Okay? So if I read this and I say you have $1,200 in your bank account. You deposit $320 from your job into your account every week. You're going to write an equation that models how much money is in your account, Y. So our equation is over here, so we need to know Y, depending on how many weeks you work. X is going to be our weeks. So X equals weeks. Oh, that's too high. Sorry. X equals weeks. Okay? So reading through that, it says you have $1,200. Right there, they gave us our initial value. And then they said, you're depositing money at $320 from your job into your account every week. So our rate of change, $320. So now we're just going to write this as an equation. Rate of change, you guys really want to know what rate of change is called? This is why we learned about slope yesterday. Rate of change is slope. So in our y equals mx plus b formula, it goes right here. So we write it as 320x, because we don't know the weeks yet. They haven't told us. And then there's our initial value, would be where we started on a graph, if we were to graph this. And there's our equation. That's all it was asking. It just wanted to know what our rate of change is, which is our slope, and where we're starting on the graph, which is our initial value. And then we just write it. Word problems are not that scary. Yeah, they scared me when I was growing up, but now I kind of know what relative information I need to pull out and what information I decide I don't need to have, because there's information in there that they randomly will put in and you're like, what in the world? You're just putting a random number in there for no reason. So much fun, right? So let's follow along with another one. Hang on one second. All right. Let's do another one. So this one says you get to go skydiving. Oh my goodness, why would you want to do that? So follow along with me here. We're going skydiving, guys. I'm terrified. This is already know what I have to set up. But we get to go skydiving. After you pull your parachute, you are 5,000 feet above the ground. You're gonna get out of here. Don't scratch that. Sorry. I'm ruining stuff. So after you pull your parachute, you are 5,000 feet above the ground. 5,000 feet is our what? Initial value. Once your parachute is out, you fall. This is the key. You are falling 6 feet per second. So we have to write an equation. You are falling, though, because you can't go up any higher when you're skydiving. So we're falling. So rate of change is actually -6. You're going down. Falling. So now let's write the equation. Well, if this is our slope, -6x plus 5,000. Ta-da! We went skydiving. We just don't know when we're going to land. We haven't given the x yet. So woohoo, right? It's so much fun. I know, right? Oh, my eraser's over here. See, word problems. Not that scary. Let's see. So what if I were to give you a word problem here. So this person is saving for college, and he has S equals 50. I hate when they write this. Undo X, because they wrote it as a T, and that doesn't help. Plus 250. Okay, so this is asking us, we need to identify our rate of change and identify our initial value. So easy peasy, what's our rate of change? Well, we look at it and we're like, well, there's our rate of change. And here's our initial value. Right? But now they're asking us something else. They're asking us, what does the point, so if we're given this point of 10, 750, what does this point mean if it were in context in this situation? So looking at it, the x value, so this is our x value and our y value. So I'm just going to change that to a y. I don't know why I did that. So x value and y value. So x would mean the number of, because if I'm reading this, I'll read you the problem. It says Manuel is saving for college. The equation x equals 50, or y equals 50x plus 250 describes the situation where y represents the amount of money in his savings account and x represents the number of months since he opened the savings account. So x is representing what? Well, x equals number of months. So what does this y equal? Y equals the total amount in his bank account. So now it's asking us, what value of the domain wouldn't make sense for this situation? Well, looking at this situation, you can common sense it. What's not going to make sense? Even in a real world situation like this, what wouldn't make sense? Could you do something that would not make sense in this situation? Could you go to the bank and say, hey, I want to put a negative amount of money in my bank account? No. So, negative numbers won't work. They don't make sense. Cool? Right. I know. So cool. Okay, so let's look at this one. So this is a linear function. We're going to model a linear function. So this is how I like to do it. So this says that Charlotte planted her tomato plant in her apartment. After 2 weeks, the tomato plant was 14 inches tall. After 5 weeks, the tomato plant was 23 inches tall. That's the only information they're giving us. So I'm going to write a chart here. This is how I like to do this problem. Okay? So we know that I'm going to write a 0, 1, 2, 3, 4, 5. Okay? And we know that at 2 weeks, it was 14 inches tall. And at 5 weeks, it was 23 inches tall. Right? Yes. Okay? So we know that much. Right? So now what I do is I'm like, well, from here to here, that's 3 spots. Mm-hmm. And then from here to here, well, that's 9 spots. Right? Because 23 minus 14 should be 9. Easier way to look at it, you could just go, what's 14 plus 3, because you're using this, you get 17, which is kind of what I did, because I just don't like to do this other way. And then you go backwards, 11 and 8. So now, I've just subtracted 3 from this, till I got to 0. because now I found my initial value. So this is what they wanted us to write. They wanted us to write what is our rate of change, which is always this one. So rate of change, initial value. Well, our rate of change is 3. We're growing, what, 3 inches a week? Right? Because from here to here, it's 3, 3, 3. So now we just write it. Y equals 3x. And our initial value of where we started is where the 0 is. 0 and 8. There's our equation. That's how I like to do those ones. Because I'm not too happy with, you know. So let me show you this one the way I did this other one. It's a bigger number. So, I'm looking at this guy here. So I have my X and my Y. It's not too high. Draw my chart. So my X is my time, because this is a ski thing, snowboard lessons. And this is my money. So this says, Carmen pays a snowboard instructor for private lessons. The instructor charges a fee to rent equipment and a constant amount per hour. Carmen paid $265 for 6 hours of instruction. Then for 8 hours of instruction, she paid $345. So I'm going to write a chart. We've got 0, 1, 2, 3, 4, 5, 6, 7, and 8. Well, we know at 6 hours, she was paying $265. And we know at 8 hours, she was paying $345. So this is how I'm getting my rate change here, is I'm going to go, well, from here to here, we get 2. And from here to here, we got 80. So I take these two numbers, and I'm going to go, what is 80 divided by 2? Well, 80 divided by 2 is 40. So I know my rate of change is 40. So our rate of change equals 40. So now I'm just going to take that, and I'm just going to go backwards. So 265 minus 40 is 225. And then minus another 40 at 185. Minus another 40 at 145. And you just keep going until you get back to where you're supposed to be. To the, that is not right, to the 0, which is our initial value. And so she paid $25 to begin with. So writing the equation, y equals 40. That's how much she's paying per hour, plus 25 initially. That is how I like to solve these ones. I just find them more, they're not as confusing when I solve them that way. I don't know. That's just how my brain works. I don't know. It might help your brain if it works that way, but if it doesn't, there's other ways to do it. This is just how I do it. It's just me though. So, let's look at, if we see linear versus nonlinear, right? Cool, huh? So basically, if you're looking at a T-chart like this, they give you a T-chart. I'm going to do 2 T-charts up here. And 1, 0, 4, 10. -5, -2, 10, 28. We'll do 2, -1, 0, 1, and 0, 1, 3, and 6. Okay, so I'm giving you 2 T-charts. So we can do it one of 2 ways. I like to do it, I think with this one, which way did I do it? So this one, I just did what's the difference between the 2 kind of thing. So right here, there's 4 spots. Right here, there's 6 spots. Right here, there's 2 spots. No, there's 1 spot. I can do math. Right? I don't like that as much. So what I like to do is I do the change in y over the change in x. That's easy, right? because that's also what we can do. But you have to do it like twice or something like that. So if I do the change in y, which is negative 2 minus negative 5 over 0 minus negative 1, negative 2 minus negative 5 is a 3. Negative 1 minus, well, 0 minus the negative 1 is a 1. So we know this one right here is 3, so we'll leave it like that. And then let's do 10 minus negative 2 and 0 minus 4. Nope, 4 minus 0, sorry. 4 would have changed everything. So 0 minus a negative 2 is 12. 4, which is 3. I'm seeing a pattern. So right here to here is 3. And this would always go down to 1 whenever I do it. I'm seeing a really big pattern. This is how I'm solving it. I know this one is linear because each one is equaling 3. So my slope of this one is 3x. 3, just 3. So that's my slope, or rate of change. Cool? I like to use that. So looking at a nonlinear one though, which I know this one will actually be nonlinear, because there is going to be no constant rate of change. This one we can do easily. I'll do it the same way. So looking at this one, change in y, so y minus 0 over the change in x, negative 1 minus 2. This one, so these two would be 1 over negative 3. So let's do this guy. So 3 minus 1 over 0 minus a negative 1 equal 2 minus 2 over 1. And then 6 minus 3 over 1 minus 0 is 3. This one has no constant rate of change, so this is not linear. Because each time I would do the difference, the change in y over the change in x, the slope changed. Each time I do the change in y over change in x here, the slope didn't change, so this is actually linear. It's a line. If you were to graph this, you get a line. That's the basis of linear and nonlinear. So, looking at it, so if we see some equations, they might give you some random equations. And they're like, well, tell me if this is going to be linear or nonlinear. So, if they give you this, or I'm just going to throw 3 equations up here, and we're just going to tell by looking. We don't even have to solve these. We're just going to tell by looking if this is going to be linear or nonlinear. So, looking at these equations, we're just going to look at them. This should be a 1 right here. Just look at these equations for a second. And just think in your head, when you're solving an absolute value equation, how many equations do you actually have to solve that equation? You have to solve 2 equations. This is nonlinear. If you're looking at the graph of an absolute value, I'm going to draw a tiny little graph of it. It actually looks something like this. It's a V pattern. That's a nonlinear equation. So absolute values are nonlinear. Looking at this guy over here, this is something we could easily just move and solve, and y will equal something, right? That right there, what do you think that's going to be? Well, it's linear. That's 1 line. This dude down here, if you look at him, he's got this cute little x squared going on there. If we look at his graph, he's actually a parabola. That's nonlinear. So if you're given a bunch of equations and they're like, please tell me if this is linear or nonlinear, and then explain why. Well, if you see this, You know, it's nonlinear. It's absolute value. It looks like this. You see something like this, it's a parabola because it's squared. But anything that kind of looks something like this, usually linear because you can move it into y equals mx plus b formula. Which is why y equals mx plus b formula is so important. And my former students hated the fact that I would constantly tell them it was important. It still is important, and it just butts up at it. Let me just tell you. You're going to use that formula for a long time. You know that. But no one believes me whenever I say it. But what did we do yesterday? Well, we learned it yesterday, and what have we been doing all day? Using it today. So, obviously, it's important. Just saying. Learn that formula. Y equals mx plus b. You can put it into your life. So tomorrow we're going to start learning about exponents. I like exponents. Okay? Hopefully this one was helpful for you. I found it fun. It was basic functions, so hopefully you found it as entertaining as I did.